Alright, time for the DraftPhysics.com video presentation. So I'm going to play a little bit of a Brozo video just because. Okay, I'm going to tend not to play any of their videos because they really can't do the simple things. You know, they can't say something like, yes, it's unethical to dox people in comment sections as some sort of argument technique. You know, they can't do that. So fuck it. Their arguments are really stupid, and you know there's something wrong with every single one of their experiments. So what's the point? And they do this crap, this quote mining shit. So this is how Brozo starts his video. So this is being fair. If it weighs half as much, it'll go twice as fast. So he plays a bus. I don't know. What the fuck? An obnoxiously horrid noise. So, and he doesn't believe that, you know, obviously, if you're using a force and you put half the mass in front of it, that it's going to go twice as fast. He doesn't think that happens. So what the fuck is this? What the fuck is that? Somebody should have to put up with this as part of an argument. I shouldn't. I don't think I should have to, so I'm not going to. But anyway, let's just, this is, again, just tolerate a little bit of this creep.
So it won't.
Yeah, so he says so, right? And I'll show you, he's done videos where it comes out exactly that way, so, you know. And what he does here is he posts an old video where he's using this shitty little solder sucker spring launcher, and he claims it works perfectly, and there's no evidence it works at all. And so there's nothing to argue here. There's no, he doesn't show you how he's launching the things he's saying. It's, you know, so there's no way to even judge the experiment.
Hello, this is a quick message to my subscribers.
Yeah, all 100 of them. Oh, 129. So, and just the scum of the earth, frankly. And, you know, all their videos, they only get like 60 views or 100 views because there's, you know, comments, and that's it. It's all comment driven.
You know, if you enjoy any of my debunking Gary
Whatever. Is that what they are? Oh, jeez.
videos,
I just, you know, I couldn't see anything other than some sort of, you know, vomit. You know.
DraftScience, that is. You will probably also enjoy my friends' channels.
Oh, brother. Yes, you probably, if this is your taste in science, yes, you probably will.
Work very hard to establish the truth. To get me, can't put me teeth in.
So he can't speak, so I should play that over and over again. I should just take out that little, you know, verbal error and play it over and over again.
We also work very hard to establish the truth about his silly claims, showing how nature really works. It takes a long time and a lot of time and effort to do the work we do.
Oh, let's understand. It's just, oh, I can't even listen to this shit. The work we do. There's deliberate effort to force engineer results to confirm. Okay, and that's all it is. They're not doing science in any way. They're just propagandists.
And it takes years to gain just a few subscribers. So
it's all about the subscribers.
I would like to spread the word about the following people and their channels. I will put
like they would think there would be a lot of subscribers for them debunking one person on the internet. I mean, it's not like there's a flat earth community here or something. There's not like there's a whole bunch. There's one person. Yeah. Hilarious.
Links in the description. Ian Gosling, Michael Fowle, Dispar's Lab, Mindless Marbles, and there
assholes all.
Are others who also argue against Gary's utter nonsense, such as Steve Godfrey, Robert Ritchie, Piro314.
Yeah, brother. So, you know, there's just no point. I mean, Steve Godfrey, he just, every video is just a huge lie and distortion. So he should just be known as the guy who, you know, is basically a wife battery defender, an apologist for wife beaters, because he's basically overtly said she asked for it. His own mother asked for it. Yeah, that's his theory on victims. Yeah, he's a real defender of the defend, the undefended. Yeah, he's a real protector. Oh, fuck.
I might be here a while trying not to miss anyone out. Some make an amazing contribution.
Oh, Jesus, this is just such... Anyway, the next part is the funny part.
Comments such as John Sean Walker. But I would be especially grateful if you could check out the latest videos on these channels and consider subscribing, commenting, like.
Yes, consider all of these things that, because you're going to do physics, and if you don't know about subscribing and commenting and linking, and you don't know what any of those things are, but you're going to understand physics videos, right? Oh, it's just so pathetic. When somebody's doing this whoring for attention, well, if you have to whore for it, then what kind of audience are you going to get? What do you think? What kind of audience are you going to get if you need to say these things to the audience? I mean, that's how little these people use anything called logic.
And possibly sharing. Thank you very much.
No.
Very little helps.
Yes.
The following is a re-upload of a video that Gary should have acknowledged because...
It's just so silly. I've acknowledged it in at least 6 videos, okay? Made the simple argument that, number one, this experiment can't tell you anything. Okay, it's a theoretical impossibility. You shoot something into gravity, it falls at a standard rate. If it's going twice the speed, it will land twice as far. There's no other way around it because you're not applying any friction to its motion in this direction except air resistance, which is minor. So the only thing that is in question is what are you using to launch the objects? And that's the part you don't show in the video. There's no indication you're even hitting the things on the center of their mass. There's nothing. Okay, it's just absolute shit. So I think that's all we need, right?
By his own words, it proves him wrong. It was him who said...
So again, more lying about anything I said. What I said is it's a simple enough experiment, okay? So you want to show something going 4 times the speed. Let's see it go 4 times the distance through gravity. Oh yeah, that's right, it won't do that. It'll only go twice the distance.
This will prove things once and for all. Hello. The following video...
So again, their argument is that something's going twice as fast has 4 times something called energy. Yet it doesn't go 4 times faster, obviously. It's only going twice as fast. Duh. So where's the energy? In what form is the energy in? This 4 times the energy. Where's it come from? Does the mass get increased because it's going faster? Its mass doubles or something? Where's the source? All right. Well, anyway, so we're not going to play. It's just crap. It's theoretical nonsense. All right. That's all you can argue. There's no theory to it. You can't sustain it as an argument that he's demonstrated that he did in fact launch them at twice the speed, which he didn't do, and obviously. And so what's the point? Oh, that's right. There is no point. All right, as for these other assholes, I mean, I'm not, again, so apparently the Gosling guy has made a video saying twice the voltage is 4 times the energy. Obviously, it's only 4 times the energy if you double the amperage. The sentence the guy wrote was doubling the voltage, quadruples the power. No, it doesn't. So you can double the voltage without increasing the amperage, and it will only double the power. It will not quadruple it. So it's only if you do both, just like in a momentum experiment. If I make something twice as heavy, I can give it twice the power. If I make it twice as heavy and I move it twice as fast, well, obviously then it's going to have 4 times the power. Duh. I mean, it's just too silly an argument. All right, so we'll show a couple of other things. So the Dispar lab, I've already pointed out, irregularities in his video, but I'll do it, I'll just go over it one more time real quickly. So in the video, he's banging something into a spring. Now, obviously, you can bend springs, okay? You can You can have a straight spring and you can bend it, and it also has a restoring force. So there's not only compressing a spring, but bending a spring. Now, obviously, that's part of the problem he had in his videos. The spring was bending. So you can't measure the distance. When you bend it, okay, it makes the distance really short. So it's, it's a it's obviously a cheat of sort, right? So you can have a spring that coils and bends, or you can have a spring that just compresses. So the point is, if it bends, it can look like it's much shorter than it really is. So that's not very useful. And then the numbers he got, it was kind of, glaring, that he's compressing a spring, and in one case, where the object only has one mass, okay, at one velocity. Yeah, no, it might have been the two mass. Okay, at one velocity versus a one mass at two velocity, I think is the way he did it, yeah. This case, he's measuring the reflection. So he's not only measuring how much it compresses the spring, but how much it gives back. And he got numbers like 1,000 and 1,600 for the reflection. And in this case, okay, you got numbers like 500 and 550. So clearly, in the case where the spring, and this is the case where the spring was bent, so clearly there's this huge, you're getting a very good correlation. Okay, the recoil is a little slower. The bigger the number, the slower it is. So it's a little bit slower, but it comes back with 90% of the energy you put in. And here it's way short. Okay, I mean, it's only 70% of the energy, maybe less. Yeah, it is less actually. Well, no, it's somewhere around there, 60 something. Anyway, very bad reflection. So what happened that the spring didn't get compressed? What's the argument? So it might have something to do with these carts had very big, very heavy wheels. So you had to convert the angular momentum also into the spring's compression. And obviously at different speeds, the cart might tilt, it might lift, it might do different things. So crap experiment, frankly. All right. So then this Falwell guy has done some crap video also, where we don't see much. He's dropping a weight from 11 centimeters and then 44 centimeters. And we don't see how he's dropping them. Again, none of these people believe in quick releases, doing anything clinically separate from human error. They don't want to reduce the amount of errors in their videos, in their experiments, and so they don't do them carefully. They do them sloppy and lazy. And so I'll go find, I have an image of that you can sort of see. So again, the frame rate is terrible. You can't see shit really. It's just so bad. Alright, so here's 3 separate images of what he recorded. Now all of these were recorded to be almost the same reading here, just a little bit off. So they all came up with the same answer. So, and you can just look at these springs and say, well, that doesn't make much sense because, there's only 4 coils here, there's 5 coils here. These are obviously compressed more than these coils are. The distance between them is smaller, so how can the coils be compressed more and yet they're reading the same on the scale? I mean, it just sort of says to you that something's wrong there, and the real wrong is that the frame rates were so bad that you don't know what this image is an image of, frankly. So this is the one that's supposed to be the heavy thing, okay, and it's obviously got huge gaps in the spring, and the ones where he has them attached, I mean not attached, that he dropped from the higher height, have this much tighter compression, indicating, okay, that something's way wrong with the way this experiment was done. So anyway, and they're even flattened out here. You can see how the springs have even started to flatten out, and they're still, wrapped around here. And there's no even indication that this spring looks like it must have compressed right up. It's gotten smaller in its size versus the other spring, which is much wider. It's going around. There's a gap. You can actually see the gap over here of the spring. So this is obviously too little spring for too much experiment, frankly. It just didn't. Just not the way to do the experiment, frankly. It's a junk science, frankly. It's just a garbage experiment, not done very well. It's not good enough. Let's just put it that way. People who can't admit that are pretty lame, in my opinion. All right. So the other thing to talk about is the Brozo thing, because it just relates to the whole lever experiment. So let's go back to. All right. So Brozo previously did a video where he was attempting to show how it doesn't work. So what he just started this video with the mocking thing, where half the mass doesn't mean twice the speed, and he basically did a video that showed pretty well that that's exactly how it works. Half the mass, twice the velocity. All right, so I'll draw it. Well, I suppose we could just play a little bit. This is just the counting. His video is such a mess, you can't actually show the things happening, because that's a tiny percentage of his video is the actual experiment. The rest of it is babble and nonsense.
Yeah, I suppose that's Bob on the edge.
Okay, so what you could notice is that, yes, it leaves long before, it's already going its maximum velocity, and it's almost like you don't need the little stopping device. But anyway, so I'll explain the experiment. So what he basically proved was, he's saying it's not 2-to-1 relationship. So he proved when both of them are on the lever, it's clearly a 2-to-1. Okay, when you have a half mass and you have a full mass here at 1 unit of distance. Now it's 1 unit of distance, you just can't see it because he doesn't have it all in the frame. But this is twice as far out as this other one would have been, the full cue ball, a billiard ball. And he got it, 19 to 11. And he says that's not a 2-to-1 relationship. That's his argument, that somehow that proves it's not a 2-to-1 relationship, that half the mass doesn't go twice the speed, when clearly, if you actually watch the video, it's clear the yellow ball is going really fast compared to the blue one. Clearly very close, if not exactly twice the speed. And so it's just, why bother? Why does he make a video, starting the video by saying somehow it's wrong to say half the mass, twice the speed, when clearly, that's what the evidence does show, in fact. Just so stupid. So I'll illustrate it. Sorry. I thought I paused. I hadn't yet. Funny. Alright, so it really was a good experimental setup. I mean, I liked it, frankly. So instead of doing the traditional lever, you're changing it a little bit. And obviously I would extend this to be the same length. Okay, but anyway, this is what he had. Okay, so he didn't have this part on here. So he connects it to a spring. And what you're going to do is pull the lever back, compress this spring. Alright, and you have a device for locking it in a position and releasing it. And, it's not perfect, but it's sort of a quick release. Who knows how good it actually is. I mean, it'd be better to have something you could just cut with a pair of scissors. That would be the more ideal, but whatever. Close enough. And all he did was put a half mass, okay, a cut down billiard ball, and the regular one here. Okay, so this is twice and this is 1, and he does the experiment separately. Okay, so you pull it back, you do the experiment with the 2, and this is where he got the 19, and there's plenty of 20s in his actual counting of the frames, and this would be 11. So pretty close to 20 and 10, pretty close to 2-to-1. But he's arguing that somehow this proves that it's not 2-to-1, even though the results are just about as close as you can get. And if you watch it visually, it's impressive in the sense that this is really fast compared to this. Really fast. But it's a good experiment, right? I mean, it gets to the point. Now, the other question is whether he's even on, he's got his marks on here, and whether he's really putting the things in the actual centers in the right places. But if you put this too far out, it'll go slower. You put it too far in, it'll go slower. So the only place you can get the maximum velocity is on exactly the right 2-to-1 relationship. To get a 2-to-1 outcome, you have to put it on the right places. Because this can't go faster when it's out here. And it will go slower if it's in here. So you have to put it in the right place. So anyway, but this just proves the point too that, you know, I mean, if I press on this part of the lever, this 2 mass here is going to weigh the same as this mass here. They're going to feel like the same thing. It's the same amount of energy to lift these 2 things. Okay, lifting something twice as high does in fact feel, okay, it's going to feel, okay, like, yes, it's twice the work. So lifting the same mass, and if you just cut the mass in half and put it further out on the lever, it ends up weighing the same. They'll balance. I can put a 2 mass here, and it will balance the 2, or it will balance the 1 if I put the 1 twice the distance. So that's the law of the lever. So, you know, anyway, so it's a good experimental design. Now, the lever experiment that we're waiting on from physicist Michael is, you know, we're basically making the same argument that we're just going to put a force in, okay, if it's a 2 mass, and our expectation would be is that a 2 mass at the same distance would leave, conserving the energy. The energy would go in here, and we'd get it back here, and we would hope to do as good as a spring or something. We'd hope to get 90% at least. That would be the hope. Now, in all these cases, you do have to physically move the lever. Okay, and so it's going to absorb a certain percentage of the energy, you know, every time you move the lever. But if you do the experiment, you know, reasonably, it'll be the same for both objects, so it won't make any difference. And so this experiment the idea would be is that you put the 1 mass twice the distance out, drop the 2 mass over here, and get twice the velocity here, okay, which would indicate you made free energy. So if you don't get twice the velocity here, then you're demonstrating that momentum isn't conserved, that the momentum of this object isn't being put into this object somehow, or you're going to prove it will go twice as fast, which means it has twice the energy. Okay, so you got twice the energy here that you're going to get here. And you're basically demonstrating that, well, if this is the same amount of energy in as it is out, then frankly it's free energy. If I can do the same energy in and I can get twice as much energy out by the 1/2 mv squared, then obviously something's broken, you know, in their mechanics. But it seems, like I said, he's already sort of proven that that's exactly what happens. It's very close to twice the velocity, extremely close, crazily close, so close that it's within 90% of being, you know, twice the velocity. And you just have to figure, well, maybe this idiot didn't quite do the experiment quite right. You know, and it would have been a perfect 2 to 1. So that's how things really stand. You know. So they can lie and cheat all they want, but you know, we have a pretty conclusive experiment from Brozo himself, and we're just saying, well, let's do it a little better. Let's get a better experiment, tighten it up, verify it even more. So that's where we really are. They're not even close to winning. Okay. They're failing dismally to provide any real counter evidence. You know, we have the Gosling case where he didn't publish the video where he was using plasticine Play-Doh and compressing it, and he came up with exactly you know, what I predicted. And you know, some would show that he wouldn't show the experiment. And his excuse was that somehow the clay was, you know, falling apart and wasn't working, and yet it worked perfectly. So yet it fell apart in such a way where the answer came out exactly my way, and consistently, like more than one time. Each time he did it, the outcome was exactly the same. And he's saying that somehow the clay is broken. Well, how could it be broken in exactly the right way? I mean, that doesn't make any sense. If, you know, you can't make that argument, frankly, realistically. You'd have to demonstrate in some way that somehow it turned out just right. by just changing the masses a little or doing something to demonstrate that, see, it doesn't come out the same when I change the mass, or I do this, or I do that. Yeah, but anyway. All right, take a pause here and see if there's anything else to say. All right, let's see if this clip plays. You see, it's so hard to find the clips in this video where he's actually doing the experiment at regular speed and you can actually see something. So you have to go looking for it. So let's just see what this is.
Just the yellow half ball.
Okay, you can see really fast. Yeah. Okay, there's in slow motion, so really fast. And now he will do the other one, I think. All right. So that's even slower slow motion. Clearly rotating in this case. In the other case, it looked like it skidded. So that is interesting. Clearly rotating. So his complaint is that one rotated and the other skidded. Well, this one's obviously rotating. Lots of rotation, actually. Yeah. You can see, very fast.
Now both together.
Oh, I don't want both together. I want just this blue one by itself. See, this is the problem with his frickin' experiments, is you can't see. Okay, here's the blue one by itself, maybe? Yeah, there it is. All right. Maybe we're not going to get a whole bunch of those, but anyway. Much slower. Much slower. So this is the mess that he shows. So obviously it's, and you could, if somebody go to the trouble, you could take the actual, find the actual little clips where they're at real speed. You could actually take the video clip of one and put it next to the video clip of the other and see if it actually is, this one only goes halfway while the other one hits the top. And that would sort of prove that, yes, it is in fact going twice as fast. But you could see it. Frankly, you could see it. Let's just play this one more. Look how slow that is. Slow, slow, slow. And then yellow.
Just the yellow half ball.
Yeah, watch. Boom, boom. Come on. Now he claims that's not twice the speed. That's his claim. He's claiming it's ludicrous, whatever the streetcar thing had to do with pointing out how it's ludicrous. It's ludicrous to say half the mass, twice the speed. It's a silly thing to argue. And here he has put up a video that just demonstrates it right in your face. It's shoving it right in your face. Here, it's exactly that. Okay. Half the mass, twice the speed. Same spring, same force, half the mass, and it's clearly going damn fast. And rotating. See, there it's skidding. Now it's rotating a little bit on the way back. So that slowed it down a hair because it had to, use its velocity to start rotating. So that was evidence of friction starting to steal some of its velocity with distance. All right. So the real point is how long does it take to hit this surface, because that's less friction. But anyway, enough said. So yeah, that was good enough as a demonstration. Frankly, you should get the point that the idiot who did this video is claiming it's ludicrous, it's silly, it's nonsense to say half the mass, twice the speed. It's a silly thing to think or to say, and here he shows an experiment that just couldn't be any closer to proving it. All right, so enough said. Till the next time and such.